I wonder what's on the telly. It's another nature documentary. Press the red button now for a fully immersive experience. God, people are obsessed with the red button these days, aren't they? Bring back teletext, that's what I'll say. I suppose I'll press it just to find out what it's all about. Oh, what? So I'm in space now, am I? Alright. Here, in the endless vacuum of space, seems the most unlikely place to find life. But here we have Geoff, the space dog. Geoff, the space dog, is what biologists refer to as monophagous, meaning he only eats one very specific type of food. Living on a diet of super spicy curry comes with a unique set of challenges. Bog! Let us watch as Geoff flies majestically in his portable toilet, propelled by nothing less than his own torrential diarrhea. Hang on a minute. Is that Matt Hancock over there? Oh no, my mistake. It's just a load of liquid dog poo. I can take what I just learnt there and stick it in that Lunar Lander game thing I'm making. Wait, what? What's that? Oh, you want me to explain it? Alright then. From the documentary, we could see that Geoff's portabog was propelled forwards by poo flying out the back. Oh, what? You want a better explanation? Alright then, if I have to. So we know when the plop plops start thundering out the back of Geoff's portabog, it shoots off with an acceleration A. And before we do anything else, we need to break down A into uppy down and sidey side. So that means, yep, we're going to have to use our old mate trigonometry again. To start with, let's look at the uppy down acceleration. And to make it easier, let's add it to our diagram, with theta being the angle between the uppy down acceleration and the total acceleration. And looking at this, we can see that A uppy down equals A cos theta. Now let's add the sidey side acceleration. And to make it a little bit easier to see, let's add the same arrow up here. So from this triangle, we can see that A sidey side equals A sine theta. Now that we've got the acceleration, we can work out the speed and position of Geoff's portabog. What? This is so boring. I don't know why I bother doing these explainy bits. I always just end up getting bored and not putting any effort in. Right, we're nearly at the end. It's just Euler's method left. And I'll do my best to just power through. To keep it simple, let's just look at the uppy-down component. So to start with, let's say our initial values at time equals 0 are 0, v0 and y0. To find the speed and position a tiny bit of time dt later, all you do is work out the acceleration at dt and then take the initial speed and add the acceleration times dt. And to work out the position is a very similar process. You take the initial position and then add the speed times dt. And then you just repeat this process for as long as you need to. Oh, we made it. We got to the end. That was probably the worst explanation of Euler's method in the world, but, well, I'm desperately trying to think of a reason to justify what I've just done, but I don't think there is one, is there? Just made a complete dog's dinner of it, really, ain't I? Oh, yeah. In the game we're making, we got gravity, so, yeah, let's just stick that in there quick before we forget. From doing this project, I learned that there is a big difference between owning a computer and being a programmer. So there we are. Lunar Lander in matplotlib, numpy and scipy. And as promised, it's not good, it's just something that exists. So don't just float around aimlessly like a massive pile of Matt Hancock. Try making your own game. Right, maybe I can make this landing this time. Well, I'm going to go and sit at the top of the stairs and pretend to be the chaser. While I'm doing that, you lot can listen to some outtakes. And then you can go away. If we have a look at Geoff's Portabog, we can see that there is poo. If we have a look at Geoff's Portabog, we can see that there is poo flying out. If we have a look at Geoff's Portabog, we can see that it's propelled forwards by poo flying out the back. And